Okay, so we've talked about the sine and the cosine. Now it's time to add in the rest of the group. So the sine is, if you recall, y over r, and the cosine is x over r. If we're in this place on a circle in the x and y coordinate grid. So we're going to introduce four more. So we have these. So the point is xy, the radius is r, the angle is theta. So we have the tangent function, and that's going to be y over x. The secant function, which is basically the cosine function upside down, or the reciprocal of the cosine function. As you can see, instead of up here, x over r, the secant is r over x. And then we have the cosecant function, which is the reciprocal of the sine. So instead of y over r, we have r over y. And then we have, of course, the bottom one is the cotangent, which is the reciprocal of the tangent. Okay, so tangent is y over x, and cotangent is x over y. All right, so we're going to use these to solve some problems. Okay, so suppose the point 5, -12 is on the terminal side of an angle in standard position. Let's go ahead and find all 6 trig function values. All right, so let's first take a peek at 5, -12. I like to put this in perspective. So it's x is 5 and y is -12, and we have a point here. So there's our r. Let's make our right angle. So now we have x is 5, y is -12, and we need to find r, because then we can find everything. So if you see a right triangle over here, then we'll see that we're going to use the Pythagorean theorem. So it's going to be, excuse me, let's go back to where we were. Okay, let's do that in blue. So we'll take x squared plus y squared equals r squared. So that gives us 5 squared plus -12 squared. And that's 25 plus 144, which is 169. And then if we square root that, we get r equals plus or minus 13, but because it's a length, we're going to take the positive 13. So now we have r equals 13. And now we can answer the question, which is, what is the sine of the x? Actually, that is our angle. That's very rare to use x. But we will, since we said, actually, I'm going to change that just so it's not confusing to theta. And then we can say sine of theta is y over r. Cosine of theta is x over r. And tangent of theta is y over x. And then the other three are just the reciprocals. So sine starts with S, and the reciprocal is how I remember starts with C. So that's cosecant of theta. And we just flip that, -13 over 12. And cosine starts with C. The reciprocal starts with S. So that's going to be secant of theta. And that's going to be 13 over 5. And then the cotangent, that's easy to remember because it has tangent in the word. And that's going to be -5 over 12. So there are the 6 exact values. Exact meaning we didn't divide them out and get decimals and round them off. Okay, let's move on to another problem. Oh, this time they give us a point on the unit circle. Okay, oops, let's get rid of that. Here, I wanted the yellow. There we go. A point on the unit circle. So we need the exact values of the 6 trig functions. Okay, we can do this. So let's look at where it is. It's 1/2. Ooh, we're in quadrant 4 again because it's at 1/2 and then negative radical 3 over 2. So it's down here. And if you look at your unit circle, you'll know that that is actually one of the thirds. So pi over 3 is up here, 2 pi over 3, 3 pi over 3, 4 pi, that's going to be 5 pi over 3, just so we know. We don't need to know that. We just need the functions. So my x is this, my y is this, and r is 1 because it's on the unit circle. So let's get we've got our x, y, and r. So we've got our sine, okay, of theta, which is the y, over 1. That stays the same. We have our cosine of theta, which is our x. And we have our tangent of theta, which will be our y over our x. So we have negative radical 3 over 2 over 1/2, which means we multiply by the reciprocal. We've worked on this a little bit, so the 2's will always cancel, and we get negative radical 3. Okay, there's the first 3. Now we get our reciprocal. So the reciprocal of sine is cosecant, s to c. And we're going to flip that, negative 2 over the square root of 3. But if we want to get full credit, we need to rationalize that denominator. So we'll times it by the square root of 3 over the square root of 3. And our final answer will be negative 2 radical 3 over 3. Well, that's a lot of work for that one. I'm going to change color to, let's go with green. So cosine, the reciprocal is secant. So I'm going to flip that. That's easy. What's 1/2 flipped? 2 over 1. And then the tangent is going to be cotangent. And I'm going to flip this, take the reciprocal of that, but I'm going to do it over here. Well, it doesn't matter anyway, because it's going to be 1 over, negative 1 over the square root of 3. I have to rationalize that denominator, times it by the square root of 3 over the square root of 3. So I'm going to get negative radical 3 over 3. Okay, so just to highlight our answers, we have the sine, the cosine, the tan. The cosecant is here, the secant is there, and the cotangent is there. All right, let's do another one. Find the point on a circle of radius 5 corresponding to an angle 135 degrees. Okay, so find the point, which means they want us to find the x and the y coordinates. Well, we know 135 degrees is going to be right here, right? And we know r is 5, the radius is 5, and we know on our unit circle, let's see, the cosine of 135, oh, they're both square root of 2's over 2's, aren't they? So we're going to have negative radical 2 over 2 and positive radical 2 over 2 on the unit circle. Let me write these correctly. Negative square root of 2 over 2 is the x. Positive square root of 2 over 2 is my y. But that's on the unit circle, so I need to say that x equals r times the cosine of 135, and in a different color, y equals r times the sine of 135. We can do that. Okay, so r is 5, so we're going to take 5, and the cosine of 135 is negative radical 2 over 2. And we'll simplify that to negative 5 radical 2 over 2. And then this y is going to be 5 times the sine, which is positive radical 2 over 2. We'll simplify that to 5 radical 2 over 2. So our point and final answer is negative 5 radical 2 over 2, positive 5 radical 2 over 2. And we would enter that as coordinates. Okay, I think we can do one more on here and take a break. Okay, here this time they give us the tangent, and it's at the third quadrant, and we're supposed to find the cosine. All right, so how are we going to do this? Well, I'm going to draw it first. Okay, so we're in quadrant 3, so I'm going to draw my triangle with my right angle on the x-axis in quadrant 3. The tangent is y over x. So that means that y is 2 and x is 7, but because we're in quadrant 3, y is -2 and x is -7. And that's very important to find the cosine, because now we know that the cosine will also be negative. Okay, so all we need is our radius, because the cosine equals x over r. All right, so all we need is our Pythagorean theorem. So let's do -7 squared, oops, plus -2 squared equals r squared. 49 plus 4 gives us a 53. So r is going to be the square root of 53. And our cosine is x, which is -7, over r, which is the square root of 53, which is not acceptable because there's a radical in the denominator. So let's rationalize that denominator. And we'll get -7 times the square root of 53 over 53 is the exact answer. And let's take a break right here on this video, and we will continue in the next problem.